I will be doing exercise 3.7. It reads, the coordinates of a bird flying in the xy plane are given by x as a function of t equals alpha t and y as a function of t equals 3.0 meters minus beta t squared, where alpha equals 2.4 meters per second and beta equals 1.2 meters per second squared. Part A asks to calculate the velocity vector of a bird as a function of time, which in part A here, you can see that I took the derivative of x as a function of t equals alpha t and y as a function of t equals 3.0 meters minus beta to t to the power 2. Here you can see where I worked it out, and I got 2.4 meters per second as one of the components and minus 2.4 t as the y component. And then B asks you to calculate the acceleration vector of the bird as a function of time. And then from there we take the formulas that we got from part A and find the derivative of each to find the components of the x and y, which we do right here, which would make the x component 0 and the y component negative 2.4. Part C asks us to calculate the magnitude of the bird's velocity at t equals 2.0 seconds. So in this, we would incorporate the first equation we got from part A and plug into seconds. And we'd only need to do that for the y component since there's no t in the x component. And then from there, we can calculate the magnitude here. Square root of 2.4 to the power 2 plus 4.8 to the power 2, which equals out to us getting 5.4 meters per second. And then part D says, let the direction be the angle that the vector makes with the plus x-axis measured counterclockwise. Calculate the direction of the bird's velocity at t equals 2.0 seconds, which we do right here with an inverse tangent, and the y component goes on top, the x component goes on the bottom, and we get negative 63 degrees. Part E asks to calculate the magnitude of the bird's acceleration at t equals 2.0 seconds. And since we already calculated the equation for that in part B right here, we know that t doesn't even involve this problem. So we can quickly calculate the magnitude of the acceleration, which ends up being 2.4 meters per second squared. Part F asks us to calculate the direction of the bird's acceleration at t equals 2.0 seconds. And since x is 0, we know that the direction goes in the negative y direction, which is negative 90 degrees. Part G asks us at t equals 2.0 seconds, is the bird speeding up or slowing down or moving at a constant speed? And from there, we know that from all this, negative 90 degrees, as well as part E, 2.4 meters per second squared, we know that the bird is speeding up.